How's it going, dreamers? My name's Acer, and in this video, I'm going to show you how to get your character in position for an animation. A great example of this is can be found in my RPG mechanics test level dream. So if we play this, the chests, when we hold R1, so as long as the R1 prompt is up, regardless of the way we're facing, the character will line up. Watch. See? So notice how it's perfect. It lines up perfectly, regardless of which way you're facing. I'm going to show you how to do it. Now, I put together this scene, and what is this scene? We have a character and a button. And if we play, and we press square just anywhere, the character does this wonderful button press animation. And if we're close enough to the button and we press square, the button presses in at the correct timing. We need to get the character to line up. So I'm going to show you how to do that. But before I show you how to do that, I do want to just go over what we have. So the character is just the default puppet, basically. And in the character, we have an animation. We have a timeline that is set to play once, hooked to the square button. The controller sensor is set to transmitter, or remote controllable, sorry. In the animation, we have a keyframe to, here, let me pin this. So in the animation, we have a keyframe at the top to keep the feet still. We have a animation in the middle, which is the button press. That you can see here. These 5 keyframes. The first and last one are blank, so the button press is basically here, here, and here. That's the entirety of the button press. And then we have a zone. Now this zone turns on a tag in the button. So this is the exact point where I want the button to go in, where I want the button animation to activate. And you'll see that this zone is sensing this tag. And when this zone does sense this tag, it will activate this animation, which is just the button press. So if we play this, it's just the button press and a sound. So I've already lined it up so that when this zone turns on, the button press will sync up with the animation. See, like that. I'm assuming you can figure this out. If not, I mean, I just showed you how to do it. Now, what I'm going to show you how to do is make it so none of the animations play until the character is in position and in the correct orientation. So obviously this isn't right. And another problem which we will fix is you can just spam and it lets you, which is a problem. So let's actually fix, well, we'll fix the spamming second because that's easy. Let's look at how to line the character up. So an important starting point for this project, whatever, mechanic, is to have the character where it needs to be for this button press animation. So if I don't do anything and just play and then press square, you'll see that it's all lined up. That's important. You'll see why soon. Okay, so now that we have that done, or well, I've already had it done, but now that you have it done, let's move on. The first thing we need to do is sense which button the player is interacting with. And you'd think that's easy, but it's a little more complicated than you think. What if there were 2 buttons right next to each other? We only need one of these to activate. So what we need to do is actually have an exclusive gate. But we need to do a couple more things. So this tag specifically is what activates the button press animation. We need a tag to just sense whether whether or not the player is in the right spot at all. So let's have a tag called interaction point. Okay, interaction point. Great. And we're going to also need a zone that senses that. Now, this zone is not going to be your normal zone. Obviously, it's sensing tags and a tag called interaction point. We need this zone to be fall off. And also, let's make it a cone, or a cylinder, rather. So this is the area where you can interact with this button. I'm going to make it a little bit closer like this. Okay, awesome. So we have this area where we're looking for interaction points. But we want it to be a fall off. And the reason we want it to be fall off is because we need to sense which one is closest. Because we want to only interact with the closest button. So 16 or 1.6, 1.6, 2.2. And the height doesn't really matter. Okay. As long as it's tall enough. Okay. So we have a zone that's fall off. Now look at this tag. Thank you for the new update that shows us this. Notice how it's not full. That's because it's a fall off. Now check this out. As we get farther away, it goes to 0. And as we get closer, it gradually fills up. It gradually fills up. If we didn't use fall off, it would just immediately fill up. But because the value is not just 0 or 1, it's a value between 0 and 1, we can use the value that this tag is supplying to basically set the priority of an exclusive gate in this in order to only have one button activated at a time. If that didn't make sense, just watch. So we have an exclusive gate, and this is going to be interaction. As long as they're all called the same thing, that's all that matters. And we're going to put the value of this tag into its priority and make sure it's modulating. And let's multiply it by 100. Not that it matters that per se, but let's just multiply this by 100. So the higher the priority, the more priority it has, right? And the highest priority is the one that gets activated. Now, 0, when this tag is outputting 0, that means the tag is not in this zone at all. See? When it outputs 1, it is as close as it can get. So, with that in mind, we're going to put that into the priority, and we're going to put a NOT gate through. Or actually, no, we don't have to do a NOT gate. Well, yeah, this will work. Yes, this is good. This is good. The reason this is fine is because it's just going to turn on this tag. This tag still needs to be sensed by this zone before anything happens. So this is perfect, actually. All right, so notice how this one is turned on. If we had 2 buttons, only one of the exclusive gates will be on, and that is dependent on how close the player is to it. Again, because we're putting the tag's value into the priority, and the closer the tag is to this zone, to the center point of the zone, the closer that number is to 1. Great. So we're now successfully sensing the closest interaction point. The next thing we need to do is basically start the animation, right? So, but one last thing to do here is that if this gate is open, so basically if this signal is allowed to pass through, turn on this tag. Allow this tag to be sensed by this zone right here. Okay, great. So this is set up We don't need to do anything else with this. So now we can copy and paste it. Actually, let's do one more thing. Let's let the player know which interaction point is being is the closest, is what will be activated, what will be interacted with if you do press square. So we simply just need a keyframe, and maybe we make the button glow, maybe we outline it with something. I'm just going to make it glow because that's the easiest thing I can do right now. Obviously with no light. And maybe I can change the color to white as well. Red. No, that's fine. That's fine. Okay. And if we have some sort of power up, it'll look a little better. And obviously, this will turn on only if it is the closest one. Great. So now if we copy and paste this button a couple of times and just start, only the closest one will light up. And that is the one that will be pressed. See? Even though all three are close enough to be pressed, only the closest one gets pressed. Now we need to move the character into place. And this happens before this animation plays. So, how are we going to do this? I like to do this with a selector. So, think of it in two different states, or actually three different states. We have state A, state B, and state C. They're states because only one can be on at a time. You can only be in one state at a time. Now, what is state A? We're going to have state A be the default state. This is when you're not interacting with anything. So while in state A, we can go into state B. What is state B? State B is moving into place. Once state B is done, once you've moved into place to press the button, we go to state C, which is actually pressing the button, playing this animation. After the animation's played, we go back to state A. So let's just handle that first. When this animation finishes, we go to state A. That's how we get back to state A. Great. How do we get into state B? Well, we need to be sensing an interaction point, and we need to press square. So if this zone is sensing a tag at all, so if the value is greater than 0, let's put everything on the left side in a chip. So if the tag is sensing an interaction point, if the zone is sensing an interaction point and you press square, you go into B. Now, when can this happen? When can you do this? You can only do this if you're in A. If you're in B or if you're in C, and remember, B is moving in the place, C is doing the animation. If you're in either of these states, you cannot press square. You cannot interact again. So you can only do this if you're in A. So 3 different conditions need to be true at the same time. You're next to a zone, you're next to an interaction point, you press square, and you're in the default state. Great. What happens in B? We move into place. Now, this is the main part of the video. This is what you guys are having trouble with. How do you do this? We are going to use not a rocket rotator, a look at rotator and a follower. Okay, great. What are these following? What are we doing? I lied. We're not done yet. We still need a couple more, just two more tags. Actually, probably just one, but 2. You really only need 1, but we're gonna do 2 just for clarity. So, 1 tag. This is going to be interaction location, animation location. Let's just call it location. interaction point. Interaction character position. How about that? Yeah, character. That makes more sense. Character position. Location implies that it's like the location of the interaction point, which it is, but still. Interaction character position. We need one more tag, and this is going to be interaction character. It's where the character needs to look at. So I guess we can do orientation, but that's not actually right. Interaction character look at. How about that? Interaction character look at. Okay, so we have two tags. Where are we going to put these tags? Well, the position is right where we want the character to go. So I'm going to put that right at the feet. Let's align the grid to the ground first. And yeah, we're going to put that right at the feet. So right there works. Great. This follower is going to follow interaction character position. 100. Let's do 99, 99. Speed is probably should be the character's move speed. Let's just leave it at default. The range keep default. Everything else keep default. Really, really important, or this is not going to work. The gizmo, the follower gizmo, needs to be exactly on top of the tags gizmo. Exactly on top. Like that. Well, actually, no, not like that. Let's align it to the grid first. There. Perfect. They are overlapping. So again, the tags gizmo is overlapping the follower's gizmo. So now the character is going to go to this exact point, but it's not going to be facing the right way. So to make it face the right way, we need this tag, interaction character look at. And here's the cool part. We're going to put this, so we're going to start it, right here. And we're going to put it all the way over here, okay? All the way over here. So when the character is interacting with this point, we're going to make him look at that point, that tag, way over there. So let's go into the look at rotator. Let's put it at 99. 99. I'm going to make it stay upright. I'm going to do stay upright. Just because this is a character and we only want to mess with the yaw. And now make sure this is pointing the correct direction. Okay, so now, oh, and of course we need to make it look at the correct tag, right? So interact character look at. Interaction character look at. Perfect. So we have these two things. We need to turn them on when you're in state B. So we have the character moving into position, but how do we know when they're in position? Your initial thought is probably to just use a timer, and that would work, but I highly recommend against that. Your next thought would probably be, what if you use a zone or something and try to sense when the character actually arrives by sensing this tag and make the zone like really small. That would work, but there's a better way. There's a more intuitive way. Think about it. Let's think about it. When the character's in position, the character stops moving, right? So what if we just sensed when the character wasn't moving with a movement sensor? Let's turn the grid off because this is driving me insane. So when the movement sensor, when the velocity rather is less than a certain number, how about when it's less than 0.1? This is completely arbitrary. It might take some tweaking. When the velocity is less than 0.1. Now this doesn't cover rotation, I think. I'm not entirely sure, but it'll generally take longer to move than to rotate, so this should be fine. So when the velocity is less than 0.1 and you're in state B, you will get put into state C, which is the actual animation. Now, there's one thing that I foresee going wrong, so we're just going to fix it right now. We need this to be true for more than a frame. So let's check if this is true, if the velocity is less than 0.1 for 0.2 seconds. 0.2 seconds. And the way we do that is put this in the reset and the power. So if this is true, how this works is if this is true for one frame, or if this is true for less than 0.2 seconds and then becomes untrue, the timer will power off, and then the next time the timer powers on, it'll be reset. So basically this means that this has to be true for 0.2 seconds. And you need to be in state B. There. And if this AND gate, if these two things are true, you get put into C. And C, of course, plays the animation. And once the animation plays, once the animation finishes, you get back to A. So this should be good. One last thing to do, you might have caught this. These tags should only be on if this is the current interaction point. So we need to do that. And if you're really tight on thermo, this tag can be used as the position. You don't have to have another tag for position. Again, I'm doing it for clarity. Okay, now this should be it, but it probably won't be. I probably forgot something, but let's test it. So I'm pressing square, it's not working. I'm pressing square, it's not working. If I get close enough, okay, so the position doesn't appear to be aligning properly. Why is that? So you see we're moving. You see it's like slowly moving. It's like skirting towards every time we press it. And I'm spamming square right now. Well, now we're not moving at all. But anyway, the reason is because this movement sensor technique isn't sensitive enough, right? So we need to... Let's go here. We need the sense, not 0.1. Let's do point. You know what? Let's check if it's equal to 0. Not if it's just equal to 0. I take it back. I don't want equal to 0 because that can get buggy. Let's do 0.01 if it's less than 0.01. Let's try this. All right, that's still not working. Maybe we do a minimum time for this as well. So maybe instead of here, let's add a minimum time. Let's add a minimum time. Let's make it 0.2 seconds is fine. So you need to be in state B for at least. Let's get a node here since we're copying and pasting it. For at least 0.2 seconds. Let's try that. Oh, I think I know why this is happening. Oh, I know why this is happening. Guys, we press the button, right? And it starts completed. It starts completed. So, okay, that actually makes a lot of sense. We don't need this. What we need to do is this. So this movement sensor shouldn't even be powered on unless you're in state B. Oh, well, no, hold on. The movement sensor should be on. This timer shouldn't be powered on. So let's just put it into here. So what this is doing is preventing this system, this thing, from even being on at all unless you're in B. So we really don't need this AND gate anymore. But what this means, the reason this will work, because this is, you'd think this is equivalent to what we had before, but it's not. Because this timer... Before, the timer was like starting completed, you know what I mean? And then it didn't even do anything. Now the timer is going to start at 0. So watch. See? And before, it looks something like this. So notice how you see it being completed at the first frame. So we're basically skipping over B. See how we're just skipping over B completely? When we put the wire here, oh. Okay, maybe again we don't use the AND gate. So, yeah. We don't need the AND gate anymore. Okay, notice how it doesn't skip over B. See? So now let's try testing it out. Okay. So we're not getting close enough, but that can be fixed. Let's just try this. Let's do this. There you go. So look at that. We get into position perfectly. See? I mean, okay, it might not be like literally perfect, but it's pretty close. It's close enough, right? To like look good. Again, this isn't real life. It doesn't have to be literally perfect. It looks like we're not getting close enough though for like all of them. So why is that? I'm not sure. I mean, we can put it to 100% strength and maybe move the movement speed up to like 6. Let's try that. 100. You know what? 100% strength is actually probably what we want. All right, we're still not getting close enough. That's interesting. We're still not getting close enough. I mean, let's just go into it. Let's see. So this is the position. This is the follower. They're perfectly overlapping. That's really interesting how character position. It's very, very interesting how they're not lining up properly. Or oh, did I just do it wrong? Maybe I just did it wrong. Oh. Okay. So I just lined it up wrong, I guess. That's my bad. Let's fix that. Yeah, look at that. Look at that. Okay, so we want him there, I think. Let's try playing the animation without moving in place first. So it was working perfectly. I just did it wrong. Okay, that's definitely much better. It's actually a little too close. Okay, there. Now let's line it up. Now let's line up this tag and this gizmo. It doesn't have to be exact, by the way. We can move either of these. I'm going to keep the follower in place and just move the tag, which is this. This is the tag. There. Now let's try it. Perfect. Okay, maybe we should turn off procedural animation. Or not procedural animation, but like the gyroscope animation. Auto look, I think. Or, well, let's get rid of auto look. I think it's that. Motion sensor movement. Okay, let's try it now. Look at that. Look at that. So the rotation's a little slow. The rotation's a little slow. Can we fix that? I mean, I assume we can, right? So let's just turn this up to, I don't know, 500. Let's try it now. Perfect. That's exactly what we wanted. I mean, obviously, if you think this is a little too fast, you can slow it down. In fact, I think the movement is a little too fast. So I'm going to put it back to 99 strength, actually, which should slow it down. Let's try it now. Yeah, that's a lot more controlled. So I'm going to go like here, and it gets perfectly, well, okay, not perfectly into place. Interesting. So why, okay, this is interesting. Why isn't the follower trying to line up with the tag. Unless it is. Maybe it is. Yeah, these aren't lined up. It's interesting how the follower isn't trying to line up properly. Yeah, look at that. That's really weird. The follower should be trying to get here. But it just isn't, I guess. So maybe we do 100% strength? Yeah, okay, 100% strength is what we need. All right. Fair enough. So I guess we do need 100% strength. In that case, let's put the speed down to 5. And let's try it now. Perfect. Look at that. That's exactly what we wanted. So, if it wasn't clear, I'm making this live, and I actually haven't made this beforehand. I figured it would be interesting to see like my debugging process and my thought process. Let me know if you don't like that. But anyway, one more thing. We're a little too close still. So let's try moving the tag away. Because the hand's going through the button a little bit. Let's try this. Okay, that looks good. What if we do this? Perfect. Look at that. You get into place perfectly. So like if I go like here or something, you will rotate and get into place exactly how we want. All right. So I'm going to end it here, guys. Oh, hold on. One more thing. Multiple buttons, remember? So we did some extra work. So what I'm about to do will work, right? Okay, hold on. Well, I have to do it the right way. Holy moly. Got to do it the right way. Come on. I got to do it the dreams way, right? Bam. Ready? So it doesn't matter which button. We have it set up so it'll work. Ooh, we found a bug. So let's fix it. You'll notice how we're targeting this one, and then when we rotate, we change targets. We don't want that. We definitely don't want that. So how do we fix that? I did not see that coming. How do we fix that? Well, we do it like this. We need to know when we're in state B, and when we're in B, we need to lock in the interaction point, right? So we need to prevent them from changing. We can do that 2 ways. Well, there's a bunch of ways we can do it, but there's 2 ways that come to mind. The first way is to literally just freeze this signal. So if we freeze this output, so if we put all these wires through a signal manipulator and just freeze it, that would work. Freeze it when we're in B and C. But there's a better way. And that way is just directly freezing the exclusive gate using gate sync. What gate sync does is basically prevents it from changing. So if gate sync is on and it defaults to on, it can just change freely. It can the gate can open or close freely. If gate sync is off, whatever this gate is freezes. So we're going to turn gate sync off when we're in B or C. And we can do that with a tag and a zone. So when we're in B or C, we're interacting. So let's just call this interacting. And when we're not interacting, when we are interacting, we want this to be off. When we aren't interacting, we want this to be on. So let's sense the tag interacting. And again, when we're, what did we say? When we're not interacting, we want this to be on. When we are interacting, this not gate will turn off, which will freeze whichever one we chose. And that's it. So we're going to set up the exact same test. Well, probably not the exact same, but a very similar test. And let's try it. So they still change like normal, but once we press square, it stays on the one that was highlighted. It doesn't change anymore. So that fixed it. Now there's one more thing. The button is still glowing even though we're way too far away from it. So let's fix that. And while we're at it, let's add a press square prompt. So we have to delete all our buttons again because we need to make a change in here, right? When this tag is not being sensed, we don't want this gate to be open at all. All right, yeah, so what we want to do is we don't want to mess with the power of this. All we want to do, since it's automatic, if the signal through the input, the gate's input, turns off, the gate will close. So instead of a not gate, what we want to do is just check if this tag is greater than 0. And if it is, put a signal through. Now, when we get too far away, it doesn't glow anymore. That's exactly what we wanted. The last thing we want to do is replace the glow, or keep the glow, but add a hold square or press square to activate. Now, we could put that text in every single button, but the better thing to do is to have a prompt that teleports around. That is the thermo-efficient thing to do. What will it teleport to? It will teleport to interact. It will teleport to interact because we have that tag right there. Interact only turns on when this gate is on. So it will only turn on for the closest interaction point. Okay, so let's do that. We need an object to teleport around. Great. Let's make it non-collidable and no gravity, weightless, everything. All the works. Let's put a microchip and a teleporter. And this is teleporting. This is teleporting to interact. And you'll notice how the teleporter gizmo is dead center, which is perfect. Orientation doesn't really matter because we're going to just do face the player. We're just going to do face the player. And we are going to do a text displayer that is in scene. You don't have to make it in scene, but we're going to make it in scene. Always on top. Face camera. And this is going to say just square. Interact. Something like that. You can make it say whatever you want. Okay. Now what? Let's make it look a little nicer, I guess. We can keep the shadow. Why not? Okay. This is fine, but if we don't change something, the text will just always be on. We only want the text to turn on when this is actually teleporting. How do we know when this is teleporting? How do we know when this is teleporting? Well, if we sense an interact tag anywhere, we can assume that this is teleporting because it's constantly teleporting to interact. So let's sense the interact tag. We can do it in the entire scene. It doesn't matter. And if the zone is sensed, display the text. And actually, we can just teleport as well. So the teleporter doesn't have to be constantly on. It should only be on if there's an interact tag. Great. One more thing we want to do, just one more thing. We want to fade in and fade out the text. So instead of turning on the text, we're going to turn on a keyframe. And we're going to set the strength of the power up strength to 0.4, and let's make it power down a little bit quicker, like that. Great. And obviously this keyframe is going to affect the opacity. Like that. And we should be good. We should be good. Let's try it. Look at that. Look at that. Oh, but oh, no. Well, obviously this should be invisible, but that's not the issue. So the problem now is that this zone is actually activating the button press, which is not what we want. Which is definitely not what we want. So how do we fix that? I mean, all we need to do is add a second tag, right? Yeah, let's just add another tag. And this tag is also going to only be powered on when this exclusive gate is on. And this tag can be it's the location of the prompt. So maybe interaction prompt position. Great. That's what this zone is sensing. Interaction prompt position. And we can also teleport to that as well. Doesn't really matter though. Okay. Let's try it now. Perfect. Look at that. That is looking good. Press square, we go right at it, and we press the button. Perfect. And one final test. The copy paste. That's not what we wanted. Bunch of buttons right next to each other. Let's try it out. So we can interact with any of them. Press square, we get into position, we press the button. It is not pixel perfect. It does not matter. If that does matter to you, I really don't know what to tell you. I guess if the animation needs to be pixel perfect, you're better off just teleporting the puppet. But this is good enough for, I'd say, 99.99% of games. I'd argue 100% of games. If it's like some sort of like you're trying to like mimic real life or something, then you're probably going to want something even more accurate, which is teleporting. But this is pretty darn good. I'm really happy with how this turned out. This exact scene, is, by the time you're watching the video, will be remixable and on the Dreamverse and linked in the description. So definitely check it out. But anyway, guys, this was really fun making this video. Most of my tutorials have been concise, to the point, and pretty basic. This is, I'd say, an intermediate one. And it was also recommended by one of you guys. It was recommended by Hello, I'm Sid. So thank you for the recommendation. I thought it was good, hence the tutorial. I hope this helps you specifically. I'm sure it's going to help others. That's it for this video. If you need additional Dreams help, I stream Dreams on Twitch every Tuesday, Wednesday, Friday, and Saturday. If you need even more help, I have a Discord and a Twitter. But anyway, guys, have a wonderful rest of your day, and hopefully I'll see you later. I just wanna be with